Tonight is all about data, databases, core data, and reading and writing to files. And I've got 3 lovely little tutorials along with sample files, so I made sure they worked, actually. So if you go to the bhacker.com website, they're all in PDF files. They're updated, brand new tutorials. Spring 2013, iOS application development, example projects. Down here on the bottom, we're going to go through SQLite Database, and I'll talk about databases as we're doing that. Core data application tutorial. So there's 2 sets. There's the solution, which is the completed Xcode project. If you can't get it to work, you can always cheat and look at this solution. The core data application, which is kind of unique in itself. And then reading and writing to files. All of these items, by the way, are stored on the device. So this would be SQLite, which is the database that's stored on the phone. And then the core data, which is, I'll explain that when we get there. And then hopefully this is the roadmap for this evening. Hopefully we can get through all of it. The 2 here are very similar. It's the same UI, it's just different concepts. So hopefully we'll be able to get that far. So at the minimum, download the ones that say tutorial on them, and you'll get the files I'm looking at. Are we ready? Very good. And before I forget to mention it, next week there is no class because it's President's Day. So we have an extra week off. Alright, an iOS SQLite database example. So we're going to design an application to store an address book. The address book will be stored on the phone itself. There's no internet connectivity, there's no exchange of data. Only addresses added on the device are in the phone. Why do we need that? Well, sometimes we need to keep track of information like scores, games. Why are you laughing? Sometimes, yeah, all the time. All right, okay, so for app development purposes, this is what you're doing the most. Trying to figure out how you're going to save your data. If you have a game, you have scores. If you have a test, you have answers and responses. You have something that you're going to need in terms of storage. In fact, all applications these days are very much storage-based. So this one here is going to keep names, addresses, and telephone numbers in an SQLite database. And in addition to the storage, a feature also to implement that will have you search the database. It's just a query. There's some assumption that you're familiar with databases. There's also an assumption that you're familiar with SQL. Although the 2 queries you're going to run are not too bad. One is an update, the other one's a select. It's not too bad at all. And as I was previously discussing before we started class, there's multiple different ways of working with data. This is just one example. We're going to see 2 more examples for local data. There's many of other ways to do internet data. And internet data is using a shared server, which is like we were just discussing a few minutes ago, shared server, where all of the phones are connecting to the centralized server location, uploading files or data, downloading files or data, sharing information between the phones themselves. The technique of the three techniques we're going to look at tonight don't deal with shared, it's localized data, which for the most part gets you halfway through your development. And then you'll definitely need to look at WebView and shared data components as well. This tutorial, however, has you add libraries and stuff, which we haven't looked at yet. So it's an interesting approach. Okay, before I start gagging here. Okay, create an Xcode single view application project. Call it something like databases. Or another title of your choice. Use the storyboard feature and enable the automatic reference counting. So I'm going to go ahead and open up Xcode. As soon as I get started, my throat gets bad. Single view application. And make sure you're in the iOS application category. And then I'm going to call this databases 2 because I already have databases out there. Databases 2. I'm going to make it for the iPhone. Use storyboard. Let me just make sure it says that. I use the storyboard support. Okay. And enable. It doesn't really matter if you use the storyboard support or not, actually, for this application. But go ahead and save it. I'm going to save mine on the desktop so I can throw it away when I'm done with it.
Do we need storyboard?
You can, yeah, select a storyboard. At least it matches what I'm doing on my screen because I just selected storyboard. The entire application runs from one view, which is kind of funny because you get to a certain point, it's like, do you need storyboard or not? Well, if it's just a single view application, it's just this file is going to be called viewcontroller.xib instead of storyboard, but we're going to essentially use it the same way as a single view. We know this is a single view. Runs in a window. Actually, we know that from the earlier class. We see view controller here, and the view controller is a single view, which is why I'm calling this a single view application. And we found out earlier we can add multiple views to this, actually, in subviews. So this is what's meant by the view. Okay, let me get rid of that. Alright, once the project has been created, we're going to configure it to use SQLite Dynamic Library. This is the first of the libraries that we're going to use. So we have this libsql3 that's during the link phase of the build process. This library is going to be included in our project. Failure to include the library will result in build errors. So this is the first time we're going to work with a library. When we get back from our little hiatus, we're going to look at multimedia files that will use multimedia frameworks and libraries. So we'll be dealing with that. So add this library and then select the target entry in the Xcode Project Navigator and then the top entry into the project name and then display the summary for the panel. Well, let me just show you what I'm talking about here. If you click on the project up here, what we want is the center panel to show. In the center panel, what we're really doing is changing the build phases. We also have build settings. The build settings are going to change the device, the platform. Don't mess with your build settings. In fact, sometimes you'll get these really weird error messages that come up, especially if you've downloaded a project and you're testing it out, and it'll say ARM7 error. It doesn't really matter what you're doing. Some of the time you can fix it, but most of the time the project needs to be recreated into something that your platform is going to support, that you have support downloaded for. Standard ARM7 is really what's current. Older projects are using something else. So if you start messing with the architectures and the build settings, you're going to end up with a project that won't compile for you, so just leave that section alone until you run into a situation where you're not compatible. In the build phases, this is the section you are going to add stuff to. What we're going to do is we're going to build in a linked binary with libraries. We have 3 by default, the UIKit framework. And this is what's called frameworks. And when we bring in frameworks, then we add support. Support from SQLite in our case, or Facebook, or LinkedIn, or JSON. Actually, I don't think JSON runs through a framework. But JSON runs through a framework?
JSON library.
It doesn't run through a framework, though, doesn't it? Yeah. There's other frameworks out there, however, that provide you some pretty standard tools. If you click on the little plus here, actually by default we get Core Graphics Foundation, which is giving us our include foundation or import foundation at the top of every one of our files, and then the UI kit. So according to our instructions, if we go back to it, we're going to click on the build phase tab, which you just did to display the build information. We're going to go into linked binaries with libraries, which we did. We're going to press on the plus button, and what we're looking for is this one right here, libsqlite 3. So click on the little plus, and this is where things get confusing. It's like, what in the world? You see there's a ton of stuff in here. Actually, there's Twitter down here too.
Right, so what
social media, Twitter.
What exactly is a framework?
Framework is a library. It's like the old days when we included stuff. It's Foundation gives us the I/O, gives us well, it's equivalent to like iostream.h or stdio. It's a foundational library that we're including that gives us a bunch of objects that we can make instances of and use. So Foundation gives us the core I/O, the equivalent to the NSLog functionality, all that foundational Coca classes, NS everything. and a string and an integer. UIKit gives us the UI. In fact, if we come back up and take a look here, what do we got in here? We have UIKit gives us UI label, UI button, UI view, UI scroll view, tab view, and there's millions of those little items. Everything that starts out UI. Everything that starts out NS is in the foundation framework. And then the core graphics framework, that's giving us our, our base graphics for color, for window motif, for various different little pieces that are associated with the UI. So it's not giving us that much, actually. We can put in different graphic packages if we want to do like gaming stuff, get, different objects. We have OpenGL, a different framework to build shapes and things and scenes and stuff. If we press on the plus, what we're going to see is what we want is LIB. So if I start typing in LIB, and then let's go SQL, and then I say, lo and behold, I've got 3 of them. And this one's the newer one. Pick the one that says 3, not 3.0. Not quite sure what the huge differences are. Actually, maybe it tells us in here. 6.1, and this one here says, it's not going to tell me. Oh, okay. Anyway, pick the lower one, the one that just says 3 on it, and then press add. And then now you see we have lib3. So in another one right after Martin Luther King, right after President's Day, when we come back, we'll be looking at AV, Audio Video Foundation, which is going to give us MPlayer and the video players and stuff. And then we'll probably get to some of the networking ones, maybe some of the OpenGL ones. There's one down here, but it requires, obviously support. There's a LinkedIn framework, there's a Facebook framework, there's tons of different frameworks. And at that point, once you know how to use one framework, which you're going to learn tonight, it's very similar to use another framework, but you need to know which method you're calling and what you're supposed to do with the framework, and then you get the documentation, or you look at tutorials online that shows you. So we're going to link this one in here, which means when we compile the program, we're going to link this library. Yeah?
Can you just go when you are doing that copy bundled resources, the item below it?
Oh, I'm sorry. Underneath it, copy bundled resources.
What is that?
All this stuff over here in the resources. Well, it used to be called resources, no longer called resources. We have all the stuff in here is over here, actually, by the way. I haven't saved it yet, but
if you want to add images and say media player and all, do you have to?
Don't put it in here, unless you're going to link it outside of the project. If you're going to have images and audio and video, just drag it into the project. It'll show up in here anyway. Because what do we have here? We have the default image. Let's see. Well, I'm not seeing it in here, but it is in this project. It's being hidden. I don't see it in here for some reason, but normally we see the items up here. I'm seeing them in here right now. Well, the storyboard's in here, and this is the storyboard that's out here. If we exit out and take a look at the project in its folder. Oh, is that not me? Okay, good. I'm hearing myself again. Here are those images right here. They're in the main folder. So maybe if I clicked on the main folder, I'd find those images. Let's see. Main folder. I still don't see the images. So. Well, the images are out here. Maybe I need to save. Yep. Anyway, long story short, these are the copied resources. They used to show up in the old project type. They were in a separate, just like frameworks is in a separate directory, they used to be in a separate one called resources. All of the XIB files, all of the images, everything that was considered a resource ended up. It's actually how Android, it's equivalent to the Android resources that holds the icons and the views, or the menus and stuff. So, yeah. Which I don't personally use. I'm going to use, for the most part, linked libraries, and I'm going to get out of this because I don't like being in this screen. Because every time I go into this screen, I have a tendency to make errors to stuff. So, all right, I'm going back to the project, and I'm going to click on the storyboard just so I can get that screen away because I don't like looking at it either. And I'm going to open up this project again. And I'm going to close this one from earlier today. And so now I've included the lib SQLite 3 and clicked on Add. So let's import the .h file and declare the database reference. So because we included the library, we need to include the .h header file for the library, which is called SQLite3.h. We're going to put it in the viewcontroller.h file because we're going to run with a single view controller. What we're going to do is we're going to add this line to the top. So I'm going to copy it, go back to the project here, click on not the app delegate but the viewcontroller.h right underneath, because this is what's giving us, our UI kit is giving us our GUI control. That's going to give us our database control. So we can create now an instance of the database object, the SQLite3 database object, and then start sending and receiving query commands to the database. So we can do it. So let's see. This particular tutorial has a lot of reading in it, so if you download it, you can probably read through what I'm skipping over at a slower pace. Before we create the database, we need to declare a variable pointer to a structure of the type SQLite3. That will act as a reference for our database. So we're going to create a reference to this database, and since we're working on a database in the view controller, it's best placed to make that variable inside of the viewcontroller.h, which is why we're using that. If we were using it somewhere else, we would put the header file in some of the other files and then use the instances there. Since we need to import it, we're going to import it in, and we're going to make use of the SQLite. That is an ideal place, essentially, to include. Now is a good time to declare a NSString property that's going to store the path to the database. So we actually create the database in a path of our choosing, well, with a few limitations, and then we read right to this database. The database is only accessible by this app. Cannot have multiple apps access the same database. Same thing true, I believe, for the Android environment, if I remember this right. Single database for each one of the apps. It's not meant to be a widespread, let's share something. We have other ways of sharing data, but not through databases in terms of the concept. So we're going to select the viewcontroller.h file and modify it, which we just did a few minutes ago. We added the header. Now we're going to add two properties to this file to create the information that we're going to need to work with the database. One of them is going to be the path, and one of them is going to be the name of the database object that we're going to use. So I'm going to go ahead and copy these guys and put it at the top of the viewcontroller.h file. In between, we know this part already, but I'm just regurgitating because some people haven't been here in a while. In between the at interface and the at end, we're adding the properties. So I'm going to paste this in here. And what am I adding? A string that's holding the database path. So I'm going to set the string. Don't have to do it this way. We could have hard set the database string and also the path. It doesn't really matter. But here's a property, and the property in the SQLite, which means this is the database object. We're going to call it contact database. And it's of the object type SQLite3, which we can get out of here. So if you didn't put this header, import the header file in, you've got an error message at this point. So the finished file looks like this. Looks pretty good. Now we need to design the user interface. We're purposely not going to synthesize, or are we going to synthesize? Let's see. Hold on one second. We're not synthesizing in this one, and we're not doing it on purpose, because I'm going to show you a little trick, actually. So we have we don't actually have to synthesize. We have auto behavior that we can take into consideration. So because my natural instinct at this point says, well, I put a property in here, let's go put some synthesizers in, which is what I want to do next. So I'm catching myself. Let's not do that yet. Let's build the user interface now, because I want to show you something I haven't shown you yet. So what is our interface going to look like? It's going to look like this. You need to design the user interface. So select the main storyboard file. Edit the user interface by dragging and dropping components from the library. View utilities library onto the canvas. Edit the properties and the layout so it looks like this. So let's go ahead and build this. This is a blank label. It's going to show us the status. So you could change the label to status if you want. So let's build this away. It's not like the calculator. It shouldn't be too bad. I'm going to take a few minutes and build this sucker. To make sure I have my attributes vector. I think this one yellow. Oops. So I'm going to put a label here. Call this one databases, database example. So I really need the database here. So I'm going to have 3 data items. So I'm going to drag 3 more labels out here. 1, 2, 3. And they're going to be a name, address, and phone number. We know we can automatically line them up using the markers here. So if we go like this and we push it over this way, we see that little blue line. It's helping us align it, center or left. So those 2 are lined up. This is lined up now. And I'm going to put 3 text boxes in here too. This one's for the name. And the address. And the phone number. And I'm going to have a status underneath it to show, and we'll see the status actually in a few minutes. That's going to be another label I forgot about. So I'll just put here status label. Alright, now we're going to add a couple buttons. So I'm going to put in here buttons. This part you guys should have down by, you guys should have this down by now. Save. What's the other one? Find or something. Find. Because we're going to search the database and we're going to save information into the database. Alright, so that's a lovely little speedy interface. Let's see, take a look here. Name, address, phone number, save and find. Looks pretty good. If you're still working on the database, go ahead and finish that up. I mean the database, working on the user interface. Now before proceeding, stretch the status label located out here. This is a mistake I usually do all the time. This label is automatically sized for the words that are inside of it. I actually created it a little bit bigger because I put status label in there. I'm going to make it a little bit bigger, stretch it out. Otherwise what ends up happening is the label will change, but the words inside of it won't show. And I'm going to center mine, actually. It's going to tell me if something was saved or something was found, depending upon what I'm going to do with the label. So I'm going to change the label by the button presses, for the most part. So stretch that label out a little bit, make sure your user interface look a little bit better. Next we're going to wire the components to the view.h file. No mystery there. So select the topmost text elements, control click them over, release them. What are we going to call them? The name, the address, the phone, and the status. We're just interested, we don't need the labels, we just need the text boxes and that one label for the status. So we have the name, the address, the phone. If you use these namings here, it'll match the code and you won't have to change the name when you cut and paste the code in. So the name, the address, the phone, the status. So I'm going to click on my tuxedo icon, get rid of the side view, and I should have the viewcontroller.h file up, in which I do. And underneath those 2 properties I put up there, I'm going to click, control drag. This is the name. Leave it on the type UI text field. And this is the address. Control drag it over. This is old stuff we've done dozens of times, actually at least 4 or 5 times for 4 nights, so that's why I'm kind of going fast through it. Control drag the label over here for the phone. Phone. Now guess what we're going to do next? We're going to connect the buttons. So no big mystery there. So the buttons are going to be the touchdown event or the touch up inside event or whichever action you like. I like the touchdown. You don't have to do that. We're going to call the button IB actions save data and find contact. So save data and find contact. So I'm going to right mouse click on save. And the touchdown event's right here. I'm going to control drag it over here. This one's going to be called save data. And I'm going to change the IB type to UI button. And then this one here is going to be find contact. Also the touchdown event. I'll just put it above it. Find contact. Change it to UI button. There we go. So now I have the two IB actions for the two buttons and the 3 properties for the text, plus a property for the label. Oh, didn't put the label in here. Let me put the label in here. The label is going to be called the status. So I'm going to change, I left out my label, maybe you put yours in. So I'm going to put my label in here. The status. So I got 1, 2, 3, 4 properties for the 1, 2, 3, 4, and I got the 2 button IB actions. Good. If you're not, catch up while I'm talking. viewcontroller.m. Switch over to the viewcontroller.m file. Let's see what we're going to do next. So on the completion of these steps, each one of these tutorials is a little bit different. This one is a rerun, so it kind of shows you the. We have the 1, 2, 3, 4 plus the 2 buttons. Don't synthesize the properties inside of the viewcontroller.m. Instead, we're going to take advantage of an auto-synthesize feature that actually exists that I never use. It's in the latest iOS. Older iOS versions don't support this. And I don't remember when this support started. It was around 5 something. Which means we don't have to synthesize anymore. So I've been teaching you property synthesize, because that's the traditional old way of doing it. So we're going to move into auto-synthesize now, which means we don't necessarily have to build the headers and the getters. We get them automatically. How do we get them automatically? So in around version 4, they made it so you synthesized space if it was called the status. You went the status space and you went underscore the status. You synthesized it to an underscore and then the same name as the property. Now I just forget that completely. Just take it out completely and just add a underscore. So it's automatically synthesized for us. So the name now synthesizes to underscore the name, underscore the address, underscore the phone, underscore the status. We don't have to put it in. You can just use those properties automatically like that. Only problem is this: if you have a current project and you go back to an older project, it's like, not synthesized. Oh, you know, or if you use it without the underscore, you get that error message. They're not synthesized. So if you don't want to use the original, if you don't want to use the original names that you've set for these, then synthesize. It's 1 line of code. It's no big deal. But this particular project is just designed this way to show you this feature. So we get auto-synthesizing with the same name as plus the underscore in front of the name. So we also get underscore database path and underscore content database as well for us. So it's properties that we created by UI elements. It's also properties that we create on our own. So don't synthesize anything. Do it on purpose. Although this is making my skin crawl because I want to synthesize. Yeah?
I'm not completely sure I've understood that. Are you saying you have to?
You don't have to synthesize anymore.
Oh, okay.
So they brought up these rules in the old days with version 3 or so of the iOS, and they said, well, if you made a property over here, these properties, you have to synthesize them. And then one version of one release of this did it for you automatically. And then another release took it away. And then another release, the latest one, auto does it for you. Yeah?
Can we see them where they are, those properties?
Can't see it. We don't have to put the synthesize in. We're going to use it in a few minutes.
Like, how do we know that?
We don't know.
Can we see in any property file?
We can see this. We can see that they're here, but we can't see. Oh, yeah, we are in a few minutes. We're going to use the names with the underscores.
Yeah, I didn't know that it was popping like the same thing on whenever I was typing in the previous lab,
Yeah.
exercises. So it was popping. I didn't know that.
It was popping up automatically for you.
So
Because you upgraded to the 6 point whatever. So this is the newest one that everyone's got. If you've been paying attention, there's been a new update out about a week ago. Now it's forcing you to do the auto-synthesize. Because it's giving you an error message if you don't do it. Or a warning, oh, you don't have to do it. Just use this. Because they're trying to get people away from synthesizing. Which, you know, it's like trained us to synthesize it, then you made it automatic, and then you put it in for us automatically, then you took it away automatically, now you're telling us we don't want to use it anymore. Okay. But I recently, actually, over the weekend, I rewrote these tutorials to include all the latest and greatest features. So this is the newer set of instructions that say don't synthesize anymore. Now, I wish they'd just get rid of this. They'd just take this out of here. I don't like this in here by default. Because when I look at this viewcontroller.m file, I'm not writing an interface, I'm writing an implementation. So I just take that out automatically because I don't want it in there. Older versions never put it in there. So maybe that'll come out in the next release, who knows. Alright, enough complaining, let's go back to the tutorial. We have auto-synthesizing now. Actually, auto-synthesizing came around about 2 SDKs ago, about 2 versions ago. But right now it's, with all the newest warnings and suggestions, they're now promoting it, so I figured we might as well just use it. So now that we have everything auto-synthesized, our next step is to create the database and the tables that are going to be inside of it. So when the application is launched, it's going to check to see whether or not this database file exists. And if it doesn't exist, it's going to create the database file. And then within the database, it's going to store the contact information that's going to be entered in by the user. Code to perform this can be placed in the viewDidLoad method of the viewController class. We all know about the viewDidLoad. We used it in the web view to automatically load a web page when the view shows up for us. So we're going to use the viewDidLoad method again in the viewcontroller.m file. We're going to scroll down to the viewDidLoad method and modify it to include the following. And I'm just going to cut, paste it, and then explain it once I paste it. Some of this is going to be SQL code. That's going to bother you if you don't know anything about SQL. If you are cutting and pasting it, don't cut the entire method out if you want to. I just basically cut out the insides of it, left the opening bracket and the closing bracket. So, of course, earlier we had cut and paste issues. And here's the method here. I'm just going to take everything out, paste in that code in the viewDidLoad that shows up at the start. That actually happened not too long ago. We'll fix those in a few minutes as pasting errors. With the order, the viewDidLoad never used to be first. It used to be last. So I'm glad the order changed automatically. I'm going to make this a little bit bigger so I can see what's going on here. I believe my quotation marks here are going to have a problem. We'll see this in a few minutes. So I have a line return is what it is. Okay, so go ahead and see if you can diagnose different cutting and pasting issues. And I'll go through the code real quick here as I fix my code as I talk through it. Super viewDidLoad. Call the super's viewDidLoad first because we're inheriting from super. Let's now load our stuff. Let's create a string. String is going to be the docs directory. Well, that's where we're going to store everything. So get the documents directory. And then the NS array is going to be the directory's path. It's going to basically we're going to have an array that's going to store the directory paths, and a string that's going to store the directory. In a few minutes, we're going to get it. And how we're going to get it? We're going to get the documents directory by saying directory paths, which is going to be our array. It's going to come back. It says NS search for directories and domains. So then we have the NS document directory, NS user domain mask. We're going to set the mask to, we're going to set it so it finds the property that's set by default to indicate the user's directory. Why don't we just hard set this because it changes with every new build. So it depends on what you've called your phone, what you have identified it as in terms of the internal data structure that's storing the paths for where files and things are being stored. We're just going to get the documents directory, which is the public folder. Think of this like a website. It's the public HTML folder that's allowed to the user to read and write, to create databases, to do a bunch of stuff with it. Build the path to the database file. Here we're going to have the database path. See now, notice this underscore here. This is one of those. Things that we propertiesed. We create a property for the database path, which is an NS string, I believe. Let's take a look up here. The database path is an NS string. So we're going to use this string with an underscore in front of it. Here's our underscore. It's going to say it's going to be equal to a new string. Alloc a new string, and with what are we going to initialize it with? Well, we're going to initialize it with the doc directory, which is the object that we created, which is going to represent the string for the documents folder. String by appending the path component context. So we're going to call the database contacts.db. I don't believe you're required to put the DB extension on there, but then you can't tell what it is in the future if it's left on there. So we have an NS file manager. The file manager is going to say initialize. NS file manager is the default manager. So the file manager is going to keep track of the files for us, and the one file we have to keep track of is the contacts.database. If the file exists at the path, the database already exists, then don't create it. So equals no. Then if it doesn't exist, then we're going to do an SQL. If it does exist, then open it up, and then the path is going to be to the information we're passing it to. It is going to be the string. We're going to use the contacts database, which is the name of the database. If we come back over here, we have a SQLite database object called contact database. So we're going to initialize the object to the database contacts.db file that's located in the directory path, if it exists. Otherwise, we're going to create it. So if it exists, if it doesn't exist, if no, then we're going to say character error message and do some SQL statement. SQL statement is going to be create table if not exist contacts. ID integer primary key. Auto increment name, text, address text, phone text. Okay, not standard SQL. However, it is an SQL statement. Can't teach you databases tonight. Instead, I'm going to tell you that this is an SQL statement. This is why you take database class, so you can understand how to write SQL statements. So there's an assumption that you're familiar with the concept of the statement. So there's queries and there's updating. And this is a create table. It's a DDL command. So it doesn't really need to know that, but it's a data definition language instead of manipulation. If it's there, then SQL is okay. Don't set it so you don't have to do it. If it doesn't open up correctly, the status of the text is going to be failed to create the table. So if there's no memory on the phone, if it can't find the user's directory, it should come back, and then this is the underscore the status is our field that's showing the status that's underneath all of our other little fields. Close the database. After you put this thing up there, else failed to open and close database if you can't open it. So if it's not there, create it. If it is there, open it. And when you open it, if it doesn't open, then you're going to put the status out. So it's kind of a crude, very fast rough through, but you can essentially do this in your app to create any kind of database you want. You have rights and privileges to go into the documents directory on the phone. It's completely opened, and it's going to be something that you're going to essentially get for yourself, for your app. So the code in the above method performs the following tasks: identifies the application's documents directory and constructs a path to the contacts database directory. This is guaranteed to be on the phone, by the way. Some certain settings may not allow you to create a new directory, so with this one you can use. Create an NS file manager instance that subsequently uses to detect the database if the file already exists, and if the file does exist, convert it, blah, 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 create the database. Call the SQL open command function to open up the database through the reference to the contact database. So this reference to the contact database object is now what we're dealing with from this point forward. We never have to run any command to actually look at the directory paths, and we just go to this database that's already created. We already know where it is. It's already opened up. It's ready to go. So, the variable declares previously is in the interface file. We saw that before. We created a property out of it. Prepare an SQL statement to create the context table. Report the success of whether or not it was going to close the database. Basically close the connection. We already have all the settings, so we know exactly where it's at now. We know it's what it's called. So now we're going to implement the code to save the data to the SQLite database. Don't really have to do anything to any of the properties. We're just going to take the text that's showing in the properties, save it to the data. We don't have to touch the labels at all, actually, except for the status label. So what do we got now? We're going to edit the save data action method, because that's what's going to be responsible for saving the data. It's probably going to perform an update for us, right? So, or an insert, depending on how we're going to design it. The method will need to open up the database file, extract the text from the 3 text fields, instruct and execute an SQL insert statement to insert the data into it. Add this data as a record to the database. Having done that, the method will then need to close the database. Kind of like what we did before. We open the database, execute a query, close the database. Why do we want to leave it closed? Because then we can corrupt the database if we don't close it. And we're only allowed 1 connection simultaneously, so we might as well just close it. So we're going to have to close it eventually anyway. So in addition, the code will need to clear the text fields already for the next context to be entered in. So we're just going to set the text to a blank string for each one of the text fields, and then update the status of the label to reflect the status of what happened with the operation, whether it failed or executed. So in order to implement this behavior, we're going to need to modify the save data method as follows. So just as before, I'm just going to cut and paste it and show you once I put it in. So put the code in the save data method. So here on the bottom, I've got save data at the bottom. It's going to be very similar to what we just looked at. It's going to try to open up the database. If there's an error in the database, then it's going to go to plan B. Update the status. No paste errors this time. Interesting. This reminds me of JDBC, if anyone's ever worked with JDBC. We have the connection object, the statement object. But it actually kind of is on the same concept. So now we have a statement object. So we already have all of the connection stuff established already. So we just have to. We're just going to send it a statement. So SQL statement object, and we have the path. The path is going to be equal to the database path that we've got set. This is pretty much the same as we did before, using the same path and the same. We have the assumption that we already have it. Otherwise, we would have not had it. So we're going to open it now, because we already created it and the view did load. So then we have the open database at this database path, this database name. And here's a string. The string that we're going to use is going to be called insert SQL. And a string with the format. And here's the string. So we're creating the string kind of like what we did up here. But instead of doing a string, we just send it the statement. More common to see the string, because now we're going to take a string that's going to concatenate other strings and then take that string and send it to the statement object. A little smoother, just showing you other options that you can do. Here's our string that's going to be used to insert. So it's going to be in a string with format. What's the format? Insert into context, name, address, phone. This is standard SQL, by the way. So this is a regular insert. And then name, address, and phone. What's name, address, and phone? Lo and behold, they're going to be converted to strings as the type. This is very similar to, to the printf command, if you're familiar with that. It's taking on escape sequences to represent the positions and the type, data type for each one of the variables we're going to send it. When are we sending it? This is the interesting part, because we never synthesized anything, but we can send it because we're using the dot notation. Self dot the name dot text is getting the text property from the name from self. Self dot the address dot text. Remember a couple of tutorials ago we saw different ways we can run the method on it to set the text or get the text. We can set and get. If we're going to do that, then we would have used the underscore because we haven't synthesized it. This is where I think it's going to totally confuse everybody, because what I would do, synthesize it with the names, not use those underscores. That way when I reference the property, I just use the name and I don't have to worry about when am I going to use the underscore, when am I not going to use the underscore. Because most people would do this. They put this in here like this. At least, and then you go, well, there's an error. Yeah?
I'm getting an error here. It's telling me to add a semicolon here.
Is this at the method header? I mean, excuse me, at the, is this, what line of code is that? Is this line right here?
At the very top, yeah.
Let me take a look.
It's copied exactly from the preview file.
Let's just do this real quick. It might be a special character in there. It's the code itself is correct. Sender. Oops. The code itself is correct. Statement, statement. Statement, statement. Yes, it needs this. Insert. Oh, where is it? One thing, someone going to see. No, that's wrong. That's wrong. Check to see if we have the matching closing bracket on the bottom. Don't put a semicolon in there. That's incorrect. Don't know why that's happening to you. At this point, I want to say it's a copy and paste error. The code looks correct. You could try removing all of the blank lines and the extra characters. There's no semicolon at the end of here. It's not recognizing it as a method implementation. It thinks it's a prototype for some strange reason. So I would pull out the center, leave the opening and closing brackets, and see if it works. And then do this. This is another way that you can do it. If you've downloaded the solution, cut and paste out of the Xcode project for the solution. So here's the solution. Do I have it? It's up here. It's called, if you downloaded it from the same website, bhacker.com, if you open up the solution, this is why I provided actually for one of the reasons, go into where that code is and cut and paste it from there. So that's going to be in the header file down here. That's going to be right here. That way you know there's no special characters from.
I just did that actually, and it gave me a bunch of errors.
Really?
Yeah.
Can't tell you what's wrong, seriously. When we're all done, I don't want to hold up everybody, but yeah.
Sorry.
It's okay. We always have the solution to refer to as well. And it could be that, are you in the saved data? Well, it doesn't really matter. It doesn't, Sometimes when you get the message up here on the top, it's because it's not recognizing the method itself. And there's something about the structure of the method, like mismatched brackets, or a line in here that's not correct. So you might go through the rest of it and see if there's some weird things sometimes happen with quotation marks. So sometimes you have to fix single quotes or double quotes that they're in the wrong text, wrong format. I'm sorry?
What is the error he's getting?
Wants a semicolon right after.
It wants them to put a semicolon right here. He wants that. That's because it thinks it's a method prototype and not. Are you in the .h or the .m? Are you in the .m? Are you in the?
I'm in .h.
You should be in the viewcontroller.m file.
Sorry.
It thinks you're writing a method prototype.
Sorry, guys.
Alright, moving right along. No, this is good troubleshooting skills because the colon, this colon here is only used in prototypes. You'll never see that in an implementation. Especially in that syntax. So, okay. So we have the saved data created and we're going to go back to the instructions here. You should be modifying the implementation file. Implementing the code for the find data. So essentially what we're going to do now is the same thing, but we're going to cut and paste and we're going to put it into the find data. What we're going to put in there is the code that's going to search the, so it's going to run a select query. So the code itself is going to look very similar, but instead of creating a database or inserting into the database, we're going to select it. We could also perform one that, let's say for example, updated. If we did that, in fact I'll leave this to you, you can have another button instead of save, it's going to add a new entry in. It'll be one that says update, and then the update would find the current person and then save the new data for the current person that was in the form. But that takes a little bit of advanced kind of playing around with. We're not going to do that. We're just going to save and find. But that's one thing you could do if you wanted to extend your practice with this a little bit more. Okay, so as previously indicated, the user is going to be able to extract the address and the phone number from the contact by entering the name and touching a find button. To this end, the touch up inside or the touch down event is going to be used. Eventually, we're going to hit gestures in a couple weeks from now, and you're going to see what the touch up inside, touch down, and all the gesture control, which is different than touching. It's pushing your fingers apart, and swiping up, swiping down, and that stuff. And you'll see it's actually quite easy to program with that stuff. You just create methods that are going to be implemented when the gesture is received, and you just put a gesture receiver or a gesture object, create a gesture object, and then you look for the different gestures. And then you'll see why we have different touch up, touch down. Everything is programmed differently in terms of the interface. There's a different concept, but it will work very similar. So what we're going to do is cut and paste this stuff in here. So if I'm find contact, I'm going to put in the body of the find contact method. And so I'm going to go back here to my view controller, to the bottom where my other method was. Actually, my find contact method was above the other one, so I'm going to make this a little bit bigger. Some of you may have already done this. Let's see, paste. Good, no pasting errors this time, that's good. What are we going to do? Same thing as before, actually, not too different. We have the database path. Lo and behold, we have a statement. And what is the statement going to be equal to? Well, we're going to check to see. This is the find, by the way. So in here, we're going to open up the database. So we're going to do the SQLite _open with the database path and constant. Make sure it's okay. If not, we're going to put a little message down at the bottom. So it can't open up the database. If the database succeeds, we're going to continue forward. And we're going to have a string that's going to be our query SQL. It's the same, it's an NS string. Same thing we did in the previous step. String with format. Select address, phone from contacts, where the name is equal to something. And now you see I'm using the underscore the name dot text. So is that like self dot the name dot text? But it's not from self. So you can see the possible confusion when trying to learn this stuff, that we have different ways of referencing name, the name, you know, and it depends on the context that you're doing and what you're including in terms of the statement. But yet it's another way of doing it. So what are we doing? We're searching on the name, and we're finding out where the name is going to be equal to, well, whatever we put in the name field. So we're going to type a name in there. Once we populate some data in there, and we're going to search. And so we have the query statement. Query statement is going to be a converted string that's going to be compatible for the SQL query that we're going to run on the query object. SQL query here, it's an NS string. So we're going to take this string that we've created with this format, we're going to convert it to a string format that's compatible with this. This is nothing more than having to convert for compatibility, data type compatibility essentially. Because that's the other thing you end up happening is when you start working with string data, and then you have character array data, and you have character data, and then converting back and forth. The same thing we actually had with the Fahrenheit to Celsius kind of concept. Taking something that's a number, turning it into a string, from a string to a number, then back to a string. So, and we're going to have a, we guys remember, okay, going back to that JDBC, it's a prepared statement. So this is using an SQL prepared statement, and most people who are not familiar with JDBC are not going to understand what I'm saying. When you connect through a driver to a database, you're actually using up network speed, or you're using up bandwidth in terms of processing. So they have this thing called a prepared statement that's used in JDBC. It's used in here as well, used in other databases as well. It means you take the generic statement, you send it over to the database. The database has it. Next time you want to run it, you just send it new parameters. And then you send it new parameters. And what are we going to send? We're going to send it a name. So every time we run the find, we can just send it the name over and over again. Less bandwidth, faster. Does the same thing as running a brand new query. We could have designed this just like we did the update. Could design it with a query. Just run the query. You don't have to do a prepare. So it's going to prepare the query statement with the statements, and then we're going to send it the statement that we're going to do here. And what do we got here? It's going to, if the statement is in the statement SQL row, it's going to find the first row. This program actually has a bug. It only finds the first match. If I put 2 Bobs in there, it's going to find the first Bob and return the first Bob. We could put a loop in here that checks again after we found a Bob. But this one is not going to do that. We're going to see the problem is actually solved by using core data in the next example. But this one's only going to do 1 row. It's going to return the first row. So in a string, the address string is going to be equal to a new string, and the new string is going to be equal to the statement 0, 1. So we're going to get position 0 and position 1 that are going to come back. We're giving it the name. We're going to get the address and the phone number. We're going to take the address and the phone number that are going to come back from 0 and 1 when we send the name. Take that, add it to the corresponding address field and then the phone number field so that we can populate it out on the screen. And then we're going to update the status so it says match found. Else we're going to come back and update the status and say match not found and set it to 0. Set the phone number and the address field to 0. And then we're going to finalize the statement, which means send it on a prepared statement, which is a slightly different way of sending the statement than in the previous. We could have just sent another query. Didn't have to do it this way. And then close the database. So we have 2 positions that we're looking at, position 0, position 1. It's sort of like an array, where the first one is going to be the first of the entire row. We're getting the first, we're not getting the first actually. We're sending the first to do a match. What's coming back is the first and the second, which is going to be the 2 corresponding columns in the same row that match the first one we gave it, which is the name. So we send the name, comes back and says, yeah, Bob's in here. Element 1 is the address, element 2 is the phone number, which is what's left in the Bob row after we return it. So we're getting the string, we're converting the string from a character array to a string, we're setting the text. We're taking from the statement, we're taking the column text for 0, the column text for 1 that's coming back from the query. And then we're going to populate it to the screen. And we're going to populate it to the screen by taking the status.text and have it equal to this, and the address.text and have it equal to the address field string. So we can take a string and have it equal to a text display because it's a string and a string works together. So what else do we have left here? And let's see, what is the above code doing? Let's see if this does a better explanation. The code opens the database, constructs a SQL select statement, extracts the records, matches the name against the user's name, yeah. And then the SQL statement is executed, returns the SQL row, indicates at least 1 match was returned, was located. And in this particular case, the matching row, the resulting data is extracted out, assigned to string objects, and displayed in the appropriate fields. As an alternative, a while loop could have been constructed to display the matching results. For the purposes of keeping it simple, we didn't do it that way. We just have the first match, and the code itself updates the status button to indicate whether or not the match was found and closes the database. We could have said 2 matches found, 3 matches found, or something if we wanted to. Optional. Well, optional is to make it so that when you type into the fields that the keyboard goes away. So we didn't touch any of the items on here outside of the 2 buttons. If we run it right now, it should run just fine. However, what's going to end up happening is, depending upon where you've put your buttons, a little keyboard's going to come up. And the keyboard's not going to go away. So we could wire all these to 1 but I'm going to do them separately, which I'm not quite sure why. But so another thing that changed between the latest and, well, actually this is about 2 Xcode versions ago, or 2 SDKs versions ago. And if you were here for the previous class, we wired the text done on exit property, so the return property. We actually went in here and changed the return key to done. Don't have to do that anymore. By default, the default got changed to done. Which makes sense, because why do you got to go change the properties on the return key? So when you press the return key, it automatically sends done now, so you can just leave it on the defaults. But we can change the exit behavior to resign the first responder, which is the keyboard. So what I'm going to do, just because I want to do all 3, I don't actually have to do all 3. The last one is the phone number. But the thing is, you might put a name in and then want to find it. When you press return, you want the keyboard to go away. Let me demonstrate the problem right now, actually. I'll run it and I'll tell you what's going to happen to it. This seems, you know, if they could just figure this one out, return, resign the first responder, just send it automatically, maybe that's going to be in the next version. They fix the done on exit. Don't have to do that one anymore. You just respond. You just automatically resign the first responder. I have a button there that says resign. So now you see my buttons are covered up. So if I type in Bob and I press return, not going away. And I click, not going away. How do I get you to go away? Can't go away. Can't get the keyboard out of there. That's the problem. So I'm going to close it. I'm going to fix the problem. I'm going to do it for all 3 of them. You're right, mouse click. And I'm going to take the done on exit. I was wondering why this one here was already referenced as a property. Yes, I remember that. Done on exit, up here on the top, did end on exit. Control drag. I'm going to call it, what did I call it in here? Name done. Actually, I'm going to put a lowercase name in here. Name done, address done, and phone done. So this, they could automate. Name done. Because who's not going to want to do this? I don't know. Maybe there's a case in which you don't want the keyboard to go away. Name done. Address done. And lo and behold, phone done. In a particular design, you might not have to do all the text buttons like this, just the last one probably. Depending upon what the text box is, what the keyboard is actually covering up, you may not have to do this at all. Some people design their interface so the keyboard is on the bottom and all the buttons are on the top. So you don't have to worry about this. So now I have the 3 done buttons. So I'm going to go into my viewcontroller.m file, and it's resigning the first responder that I'm going to put in here, and the code for it looks like this, and it's going to be the same for each one of the buttons, which is easier for me to copy than it is to type. So this is the name, design first responder. Basically says whatever response, which was the keyboard, nothing else responds. So if it was the keyboard that went, or could be it could in rare occasions it could stand for other things. But whatever it is that responded to the first event that occurred is the first responder. So it could be a notification that showed up. It could be, I don't know, an alert of some sort that showed up. You can get rid of it that same way, actually. So let's see. The name, resign first responder. Actually, I can probably type in the rest of this. Here, let's see. Paste. This one's not going to be the name. This one's going to be the address field. The address. See, I don't think they know about the no basketball. TA. Let's just wait till it gets loud. And this is the phone. There we go. So I have the 3 in here. I don't think I have a TA anymore either. He's out playing basketball. Oh. I'm sorry? He just stepped out, okay. No, I'm good. Until they start really playing hard, I'm good. It's just a little distracting sometimes. I don't think they realize that there's a classroom next door. Oh, they do realize. They're just not being polite. So now, when I type in Bob, and I press return, the keyboard goes away. And I'm going to put him at 123, and his phone number is going to be 555. So it still says status label on here. So when I press save, now it says contact added. And now it thinks it went away. So if I put in Bob in here, I put another Bob in here actually, and he's at 999, and his telephone number is 9999. And I save him. Now if I find Bob, he's only going to pull up the first one. 123 555. Just says a match found. So it didn't clear it though. So I'm going to put here Alice. I could change it so once it, well, you'd have to have another button that said new. And new would clear out the existing data. So now I can save it because the saving cleared out the data. So now I can search on Alice. And we should find Alice. So now we have a database program. Keeps track of stuff. So users can use it to enter in scores and, I don't know, do something. And then when the program's over with, we know we can do this, right? Wow, we have a bunch of junk on this simulator. Which one is it? Database 2 comes back. Actually, and we can find it's persistent. Bob. Actually, the big test would be to, oh, he is 111. He is like this. Probably expect. The big test would be doing this actually. Closing the simulator. Actually, we're running a new instance of it. I'm installing it over again, so that just cleared out my data. Yes?
Can you see where it's creating the database and now it's creating the fields?
No. It's hidden. It's in the directory. If you exit here, I don't know, actually, seriously. Let's see if I can get back to here. I guess I can go into settings. If you put in a file manager, like Linda file, I believe it's called. If you install it, I can't see it on here, but if you install a file manager, I could test it out if I had my iPad with me today. Or someone can test it out. Load down, here's the one you want is going to be, whoops, not a server not found. Going to be, oh, no internet access either. Wonderful. Internet access earlier. Okay, let's see. Let's see. I think it's going to be called Linda File Manager. No, that's nope. Okay, that's Android. There is a file, and that's an Android file manager. There's a file manager for the iPhone. If you install the file manager and you look in the user directory, the documents directory, you possibly could see the contacts.db file. You can't like debug it to watch to see what's going to happen while it's going on. But the emulator does have a few features to it, but I don't believe it has a. It's different from this contacts, which is different. Who are these people? But if I hadn't loaded it twice, every time you click on it to install, it installs it fresh. So now my program here, not this one, this from earlier today, it's going to be empty. Oh, actually, no, it's not going to be empty because if the file existed, we never deleted the file. If the file existed, which it does exist on the app, we reinstalled the app, but the file is still there. Yeah?
I'm trying to run this app, but here it's going back into some pause mode and some thread 1
I'm going to have to see it at a break because that's going to take, you mean in here?
I'm trying to run this app.
Okay, hold on. Let me pause this real quick then. You know how to clean the project then? Okay. For those people who don't know how to clean the project cleanup here is going to be your last resort. If, let's see, do not show this mess. Oh, yeah. It's running, so I have to stop the emulator. It's going to clean out the memory, so when you build it, it builds it fresh. I can actually make this, I can duplicate your problem right now, actually. This is garbage because I already have this saved somewhere, so I'm going to try and duplicate the issue that you're having. If you go into View Controller as an example, and I say, you know what, I don't like this thing called the name. I'm going to get rid of it. I get rid of it. And then I say, oh, you know what, I want it back. And I put it back. I call it the name. Well, actually, I'm calling it the name. Let's change it. The new name. I only have to change it a few other places. Now I have a new property, the new name. And then I go in here. In fact, I can easily find where this new name is. Because it should be highlighted for me with little red marks. Here it is. The new name. Lovely little syntax errors. And then over here again. The new, if I spell it correctly. And one more spot, I believe. Oh, two more spots. I didn't think it was going to be, yeah. I believe I'm going to get some really weird compilation error. But let's see. Watch it work.
Is there something known as refactor in this so that we can, if we change in one place?
And not that I know of. No, bomb out, bomb out, bomb out. Oh, look at that. And I'm going, what's wrong with my code?
Yeah.
It's an Xcode bug. Unfortunately. So I'm going to stop it and I'm going to go, okay, now I know I shouldn't have renamed that. Let me try to fix the problem. So I come over here and I go clean. Clean will actually probably fix this issue. It's because I had the name in there and the memory was holding the name. So I'm going to run it now. I've cleaned it, so I'm going to run it. If that doesn't fix it, I'm going to close the project up. Clean the project, close the project. Okay, that didn't fix. Okay, so I'm going to stop. I'm going to clean the project. Close the project. Close the emulator. Here's my project. Open the project back up. That's why I said never delete anything. Even if you don't want it anymore, just leave it. Just comment it out and say, hey, Xcode's not going to be friendly with me. Clean it again. Then run it. Aha! Aha! I think it's going to work. I'm sorry, I had a question while I was playing around.
Yes. So when you delete that application, for example,
Oh, it didn't work.
the
Thought it was
database
there, yes.
will not exist, or the data within the database will not exist anymore, or it will exist.
If you delete the context.db file, everything's gone. All of it's being stored in the file.
So if you stop running the application, that does not apply. Right?
Correct, the file is going to be there. So as I was trying to demonstrate before, actually I closed the emulator and reinstalled the app and the file was still there because I never removed the file. Which means I kind of left junk on my emulator. But if you leave junk on your emulator, it's real easy. You just go like this and say reset the content and settings. Reset. Now if I run the app, actually it's gone. Now if I run the original app, because this one's broken now, the data persists past the app running, will stay on there until you remove it. So unfortunately for whoever installed it, who has installed it on their device right now, it's going to be on there after you remove the app too. But you can get like a file manager and remove the file. So now if I run it, I know what your question was, hopefully I'm answering it. Well, now when you run it, the data will stay in there, the database will stay in there, the context I've added in the database will stay in there until I physically remove context.db.
How would you remove context?
Well, right now we have a flaw. It's on there permanently. in this app. So we would have to delete the database, which is another command. Actually, we can use a file delete. In fact, the next example I'm going to show you will show you how to do it. You have to remove the file. So we can add files. So the next example is going to be core data. But what you do is you just delete the file. Look for the file contacts.db and delete it. It's just a file, and it's going to be stored in the user's database directory, or user's documents path. So you can probably find it if you install a file manager. Install it in your application. If you have an uninstall feature of the app, like a remove database button or something, you can have the button delete the database, reset the database. Actually delete it, because the app delegate, the view did load will automatically create it again if it's missing. Did I answer your question? You have to remove the file.
Right. So if I, for instance, deleted this app that's currently running on the simulator, the data
It's still there.
is still there.
Yep. Until you reset the contents. If you reset a phone, the same thing happens as well.
But if I wouldn't be able to access this data on any other phone. It would just be, it's just on
Correct.
this,
It's just on
one
this phone. Yeah. Correct. So it's not going to solve any of your internet problems.
I understand.
Yeah. However, if you can read and write to files, you could download a file, read to it, write to the file, upload it somewhere if you wanted to do it that way. All right, so any questions on the database before we continue?
How do you hide this keypad?
Excuse me?
How do you hide this keypad when you're typing?
Oh, you want to send a resign first responder? It's the last part of that tutorial to get rid of the number pad. When you press return, so wire the did exit on something or other, did return on exit, did exit on something or other. Maybe it's up here. Did end on exit. Wire the did end on exit action on the view controller, and then in the view controller.m add the code to resign the first responder for each one of them. You have to give it the name of the text field. You can have one actually do them all if you want to, and just have them all wired to the same event actually if you want to. You don't have to put 3 of them in here. You can have one, and then all of those actions are wired to the same, three different text fields. This is kind of redundant. If you're doing that, then you put all 3 of these lines in one method instead of in 3 different methods. Build the application, run it, and then you're done. A little bit on the end here. Not too bad. Core data. Core data is kind of interesting, actually. We're going to start out with an empty application, unless we have any other questions. We're going to start with an empty application, show you something that was originally designed, does not have anything to do with SQLite support. So people who like databases and like SQLite will use that. People that don't, you can learn a totally different way of doing it that doesn't involve any SQL knowledge or database knowledge. It's called core data. Around from the beginning. I don't know how much longer it's going to be supported. It is currently supported, however, in the current 6.1. Really easy, actually. We're going to do the same thing as we did before. In fact, we can probably take some shortcuts if we wanted to. We're going to create this time an empty application. See what an empty application looks like. Currently, only the master detail application, utility application, or empty project templates offer the option to automatically include support for core data. So we're going to create an empty application so we can get the core data. And we'll see how easy it is, and we'll see how this automates the process, actually. And it's a little bit easier than using, so we started with the hardest technique, and we're going to work to the easiest ones. And using files is even easier, actually. So we'll wind down with the easiest at the end. So let's see, open up Xcode, create a new project. This one here, select the empty application. We don't want a single view controller with a view controller. We're going to add it, actually. So we have an empty application. Click on next. Doesn't want us to call it, I think it doesn't really matter. Core data 2. I'll call it core data 2. build it for the iPhone, and then now we have this new option that says use core data. So we have this option here. This to use it. We want to use automatic reference counting. I believe we want to keep everything on those defaults. Just make sure here. Use core data. Use automatic reference counting. In addition to the usual files I presented, we are also going to get one that says this on it, which is our core data file. So let's take a look at that. Actually, let me finish creating it. Next. Next. So now I have a project here that is of a generic type. And I have this core data 2.xcd data model. So it's a data model that is supported, and I don't see anything else in here. I think some supporting files down here with some main and everything else that's associated with it. But I don't see any view controllers or anything. It's an empty application, which means I'm kind of working from scratch. And I'm working from scratch because I wanted to add this core data. Otherwise, the utility also gives it to you, and some of the other original project types will give that option to you. So what are we going to do here? If we click on this option here for the core data, we see some entities on the top. We see fetches and stuff. So let's take a look at the instructions here. We're going to create an entity description. So the screen looks like this when we click on it. To create an entity description for the core data application, you're going to select this file and load the entity editor. Well, that gets loaded automatically for us. To create a new entity, we click on the Add Entity button. We want to call the entity Contacts. And unfortunately, when I did this screenshot, it showed a pop-up menu here. So Add Entity is on the bottom here. So anyone who's taken database classes and has heard of entity relationship diagrams, that's what it means. Entity is equivalent to objects. So why didn't they call it objects? Not because it's a data element. We're going to create a new entity. We're going to call this entity Contacts. So Contacts. Press return. Then we're going to have attributes we're going to add to this entity. I'm sorry? Say that one more time.
She wants to know how to build an entity.
Oh, click on it and good question. I've never, you can change the name. I can't tell you offhand, but I'm sure there's got to be a way. What if you press the delete key? But you know what, I wouldn't trust deleting. Just leave it. Just leave it. It's okay to have two. If you delete it, might end up with the same situation we ended with last time. Don't delete anything. Okay, so we're going to add some attributes to the entities. It's like entity relationship diagramming, by the way. If you're not familiar with that, it's like an old style way of doing UML, but with structured analysis and design instead of object orientation, which is the basis for database development. Anyway, we're going to add an entity button, call it Contacts. We just did that. And then with the entity created, the next step is to add the attributes that represent the data that's going to be stored. So it's pre-database, if you think about it. It's before, because in database design, you create the entity relationship diagram, you take the diagram, you translate it into database tables, you build the database tables. So we're just going to build the diagram.
Similar to the access database?
Yes, very similar to the access concept. In fact, you can show entity relationships in Access. There's a button for it. But we're not going to see it graphically. Instead, we're going to see it in that ugly little screen that looks like this. So we're going to add 3 strings. You probably can guess their name, address, and phone number. This is the same theme and the same concept as we did before, but we're going to use core data instead of using a database. And we're going to see it's a little bit easier, actually. So add from the attribute button, we have a plus next to the attribute button right here. And in here we're going to add it, and then we're going to repeat the steps. We're going to put a name, address, and phone number, and we're going to notice that the order doesn't show up right. Don't worry about it. So with this contact up here highlighted, put a name. Actually, I'll put lowercase name. Undefined data, if I click on there, change it to string. And then I'm going to add, and then you say, what happened with their address? And don't worry about the order. And then add again. Phone, and like it's in the middle. String. So now I have undefined. Let's change this from the string. Now I have the 3. Again, a little buggy. It's not the best interface. But hopefully they'll say string name, address, and phone number. Okay, good. So I'm going to go back to my instructions here. And the entity is now defined. What did we just do? We just found the local directory. We just created our data. We'd like to see if contacts.database was in existence. We created the database file, or we opened it up, and we ran the query command to create the table and add these fields to it. Now when we delete the application, so does the core data. We don't leave some contact.db file around to get rid of. So don't worry about it on your device. You can delete it. It's not that big anyway. It takes up, very small amount of space. Anyway, so let's see. Now we're going to add the view controller. So the only problem with the core data is we had to start with an empty application, which means we have to add a view controller to it. No big deal, actually, because you know how to do this. So in order to automatically add the core data support for the application, we have to choose the empty application type, which didn't give us or anything, so we had to create our own view controller. Some people like the empty application because then they can add a tab controller instead of the view controller or something. They can specialize or customize without having to remove stuff and just create it from scratch. Believe it or not, when you remove files, you don't have the same problem as when you remove properties. It's only those properties. When you delete those properties, your application is hosed at that point, unless you're lucky enough to revive it somehow. Within the Xcode project navigator panel, control-click on the core data folder entry. Well, okay, we'll just save you. We're going to go file, new. We're going to create a new view controller, UI view controller, and name the class core data view controller or view controller, whatever you'd like to name it, with an XIB. Make sure targeted for iPad is off. Click on next. So let's go into Xcode. You click on the project up here at the top. So you're in the project folder, file, new, file, Objective-C class. Make sure you're in the Coca Touch category on the top. We're putting a new class in there. It's going to be a view controller, so it's going to be next. And you see how it says UI view controller automatically. If yours does not say that, by default, I don't have a view controller, so it's going to tell me by default I need a view controller. You can click on the little arrow down here and change it. Another interesting thing about Xcode is it happens to sometimes stay at the last option you chose. So, and it was in a different project that you were using it, but it's still there. So this one's going to be called Core Data View Controller. And then don't select the targeted for iPad because we're not using the storyboard here. We're just going to do a single view, actually, which is going to give us, with the XIB for user interface, if I click on Next and then click on Create, I have essentially a single view application at this point. I have, from an empty application, I've added and created a single view application just by adding that one view with the view controller in there. But now I have core data as well. So I can close that screen. Alright, so now what I'm going to do next, we're going to go to step 4. We're going to modify the app delegate. So in the Objective-C class earlier, we modified the app delegate to load something. Can't remember what. We're doing the same thing actually. Currently, we're not loading any view controller because we have an empty application. So we're actually starting with a clean slate. So we're going to add the. Actually, we did it for the category. That's what we did, I think, or protocol or something. Can't remember. So at the top of the app delegate.h, which is the delegate that's controlling the flow of the application. So an instance of the view controller declared in the interface file. You modify the did finish launching with options method located in the. Eventually, we're going to modify this method to initialize and locate the core data view controller instance, and assign it as the application's root view controller, because by default, view controller is the root view controller by default, which is why we can just start a single view application, and then the view controller just comes up with that default single view screen because the app delegate by default is already set to load that as the root view controller. We did it for the navigation bars. That's what we did it for. We changed the controller. That's what we did it for. Okay. So let's see. Import this here. So at the top of the file, add the import for the core data, and this is going to be an appdelegate.h. So appdelegate.h, which is right here. Don't worry about the location of these. I clicked on this up here, which is why these files ended up here. If I wanted to, I can drag the files and stick them in the core data 2 directory if I wanted to. So at the top, right underneath where it says import UI kit, I'm going to paste in here the core data view controller.h. And I'm going to wonder why in the world did that happen. I'm going to make sure I cut and paste it correctly, which I did. And I'm going to say that the name is wrong. What did I call it? Core data. I misspelled it. Bummer. That's okay, I can just misspell it everywhere else. You get the point. Name it whatever you called it. Stick it in there. Alright, let's go back to the trusty instructions. Now I gotta change all over the place now. View control draw. Alright, so now we have at class view controller. Oh, we also need to stick the class in here. We need to put both of these 2 lines in between the interface and the end. The at class is how we bring another class into the hierarchy that is not part of the single hierarchy. It's from a different hierarchy. What we're doing, and that's not going to give me that error, is it? There we go. Intra, data. This is not multiple inheritance. It's making a wider view. So it's not coming from the UI, it's not coming from anything associated with this hierarchy. So we're making it part of the hierarchy by saying at class, adding the class to the hierarchy, which means we can now extend the behavior and overload and change it if we want to. In the Objective-C class, I believe I'm going over that in a couple weeks from now. We're going to hit that eventually. Okay. We're also going to add a property. So these 2 lines of code went at the beginning, in between the interface and the end. Let's add the property because we need to create, and we're going to create a property for the view controller. So let's see, which is good because then my misspelling doesn't really matter at this point. Here's the interface. I'm going to add a property on the top. Change the data correctly. But now we're going to refer to it as view controller. And we also have a UI window that is now called window. We can put views in here and call them views if we want to. We can put anything in here. These are instances, properties of objects that we're going to use for references to the objects themselves that exist out there on the UI. So here's a name context model, data model. Okay, persistence data. Okay, so I'm going to leave the rest of it alone. So now we're going to go into the appdelegate.m and add some stuff to the do finish launching with options. Because appdelegate, this is the same method we updated earlier in the Objective-C course with the launching options. And initializing it here, we're going to add the following line to the bottom of the application method just before the return yes line. So instead of taking the entire method and giving it to you again, I just gave you the one line because I redid this tutorial so it would be a little easier. So we're also going to take advantage of the auto-synthesize, which means we added this property to the view controller, so when we access it over in the .m, we can just use the underscore view controller. So here's this is the method that we're modifying, the same we modified earlier today. It's the first method that runs, it's kind of like the view did load. First method that runs when the application loads up. And this is the did finish loading. So right before the return yes, I'm going to paste in this line of code. And what's the line of code going to do? It's going to load my view controller. view controller is going to be equal to view tra controller alloc. I have to change mine because of the I'm going to call it core data view controller though. Hopefully, yeah. Notice I'm using the underscore because I did not synthesize anything. And then I'm returning. So if you called your view controller something else, go ahead and change it. Otherwise, that line of code should implement correctly. Now your XIB file interface will launch automatically when the application loads. Run the program and test to make sure that that actually happens. So I'm going to change this background color because I don't like looking at the white. And I'm going to launch the application to make sure my XIB file loads correctly. I do this because I won't get halfway through the program and figure out, oh my god, there's one of those little memory errors that are just going to happen and I'm going to have to start over from scratch. So if I have to start over from scratch, I'd rather start over at this point. Now if I had another view controller in there, ooh, look at that. Why do we have this? Yeah, I think you might be right, actually. Let's stop it. Let me edit that code real quick. If not, then I'll rename the file. I don't think... yes, it is with nib. It's loading the wrong nib. You're right. I'm going to leave it alone rather than trying to change the X. This is the nib, but it's loading the nib from datra instead of dater. Data. Let's make sure this works. So that's a good thing I checked it now. I'm waiting till later. Ah, see that? Thank you. You have it correct. So now I have a working program, at least to this point. Alright, so go ahead and shut the simulator down or leave it up if you want. I'm going to shut mine down because I have too much memory going on here. Alright, so if you didn't call it the same thing, make sure the nib is pointing to the right view controller for the right class. Here. Okay, let me go back to the instructions and see where I am now. It does run connected. And now we're going to design user interface. This is the no-brainer part. We just did this. So go ahead and drag and drop. And here, I'm going to do this at the speed of light just to get mine done here. We got a label here. The core data. There we go. Label them. I know I could have cut and pasted it. And build your interface real quickly. Slightly different look and feel, but it's about the same. Save. Find. I could have theoretically dragged and dropped the other view controller in here. In fact, if you want to do that, go ahead. I just don't want to take the risk. Because I don't want this is just as easy just for me to quickly do this. Okay, TA. They seem to think it's okay to play basketball again. Next week, that will not be happening. All right. So now that you've got your user interface created, user interface here looks like that. Yep, looks pretty good. My color green's a little off, but it's okay. Note that before proceeding, stretch the, let me stretch that status bar. Excuse me, that status message out a little bit. Because you know what, I forgot to do it. So I put that little note in there so I'd remember. Otherwise I have to fix it further down the road. I'm going to center the text. There we go. All right. Okay, next you're going to write the components for the viewController.h file. This is the same thing we did before. We're just going to touch the, we're going to add the information. We're not going to synthesize. We're going to leave that auto behavior on its own. And we're going to change the, we're going to add the connections for the name, the address, the phone number, and the status. And then we're also going to wire the save data and the find contact. So if you cut and pasted your XIB file from the last project in here, which I know some of you probably have done, then you just have empty bubbles over here. If you have empty bubbles, you need to do it the opposite. Connect them this way into the UI. Otherwise, I'm going to do it this way, and I'm going to say the name. And call them the same thing, because then you don't have to worry about the changes in the code, the address. So if you pasted the, just to reiterate the point, if you pasted the XIB file in from the other project, dragged it, put it in, these are empty. So you go dragging them in the opposite direction to connect them. This is the phone. Perfect. And then we have the status. Alright, very good. And then we're going to do the touchdown event for these two buttons here. So we're going to do touchdown. Drag it over here. This is going to be called save button, no, save data. And then we have the find contact. Alright, so we have the two buttons and we have the 4 properties. Now we don't have to synthesize, if you remember. I'm going to change over to the core data.m file because we're going to cut and paste and put the code in for the 2 buttons. Same thing as we did before, we just have slightly different code, and this is the interesting part. We'll take a look at the code difference. So we have 1, 2, 3, 4, 1, 2, looks the same as before, don't synthesize it. In the viewController.h file, because we added this after the project was created, we need to import the appdelegate.h. So in the viewController.h, import the appdelegate.h file, which will be required by the code added by the viewController later in the tutorial. So put this right underneath the existing import at the top of it, because we're going to use stuff in there. Actually, in our particular case, I don't think we're going to be using anything in there, but because we put this in last, we'll just add it to the top. And I have a typo in the slide. There is no, that's not in the slide. So I need to correct this. Okay. Importing it may or may not necessarily be needed at this point, but I can't remember. I don't believe we're going to need it. No, actually we did for the core data. Saving data to the persistent store using core data. When the user touches the save button, the save method is going to be called the same as before. It's going to implement the code to save the data. Let's take a look at the code here because it's a little easier, it's a little bit bigger. So we're going to cut and paste and put this in the viewController.m under the save. And this is the code to save. We are needing it for the app delegate. So we're going to take the app delegate, which is from the UI application, shared application delegate, which is the delegate that's controlling our view, and the managed objects that are in the view. In the app delegate, we added in the core data, and which was there automatically when we created the project, and then we added in our view to that. Now we're loading the view, but we still have to have awareness and use of the app delegate, which is going to house our core data. So it's our direct access to the core data. This goes back to the traditional object view controller, or the model view controller, excuse me. Simple object orientation model view controller. The view is the view, the window. The view controller are those class files, the view controller. The data, or the model, is the app delegate. The app delegate is it's managing the data and delegating the control to the view. and also control to the core data. So it's almost like the, what do you call it, the guy at the traffic signal that organizes stuff. He's controlling the flow of traffic. So we're making a new instance of the app delegate, calling it app delegate. It's going to be equal to the new application, shared application delegate, which means let's share the information in the application with this view controller. What's in there? Well, that's going to be our core data. So we have our NS managed object context. So it's a managed object by the app delegate who's delegating the sharing. And it's going to be, we have the create a new contact object. That's going to be a managed object, and that's going to be new contact is going to be equal to, well, open up the entity contacts. So insert new object from entity for name contacts. And then in the managed data object for contacts, the new context set value of this name here, which is name.text, address.text, phone.text, for key name, address, phone, which are the three attributes that we created in the core data. See how much easier this is? And then, oh, this is just UI look and feel, make it all 0. I mean, empty out the contents of these fields after we make it, clean slate. And then do some error checking here, NS error, create an error object. So if the context save error, if we have a problem saving it, trigger an error. And then take basically the context here, the status.text is going to be equal to the string context saved. No opening up of any file, no creation of any database files, no connection to opening up any database connection, no running any query, no returning any results, populating it out, and then closing the database. A little easier. That's why it's still around, still supported. So is there a difference? More automated for you, not quite as much control. We'll see the find actually, and we'll see some automation for us that happens automatically. I have to put this into my project in order for it to work. I'm loading this up into the saved data button. Here's our saved data. And paste. And good. No messages. Very good. I'm just going to leave it formatted like that. Instead, I'm going to move on to the next one. So the above code identifies the application delegate instance and uses the object to identify the managed objects. Yes, we saw that. Context is then used. There's something in here I haven't said yet, so I'll skip that. Retrieving the data from the persistent store using the core data. Persistent store means it survives past the running of the application. Same as the database, has the same feature of that. So when we close the application down, when we uninstall it, it gets removed because it's part of the application. It's not a file that was created by the SQL database that's stored in the documents folder. Instead, it's part of the application, so it's stored with the application. But it gets updated and can be updated and saved with the application. It's actually just another file stored in a different location that's accessed differently. No query. It's automatically part of the data component. So in order to allow the user to find a contact, it's necessary to implement the find contact method. So let's see. As in the save method, the method will be identify the application delegate. Again, has to make a new instance of the delegate object. We could have just used the same one. So this is a little bit redundant. So if you need to obtain an entity description of the contacts, create a predict to ensure that only the objects with name is specified or retrieved, yada yada. Okay, here's the code here. What I'm saying is we created a new one here. We could have created one could have created a property actually in the view controller and then just called that one over and over again. So this is not quite the most optimal implementation. Well, it's just this extra line here. And what are we doing here? We're just basically doing the same thing as before. Managed object is the context. The context is going to be the managed object context. And we have the entity descriptions that are going to come back. And the entity for name contacts, put that into the context fetch. So the NS fetch request on the request is going to get the information out of the entity description that's given to us for the setting the entity here. Request from this. Set the entity to this entity description, which is going to be the contacts entity. And then NS predict from format name equals predict. Well, okay, so it's predicate, predict. Anyway, long story short, it's not a query. It's not a query. It's a separate method that you're running to request, to get information request. So request sets predicate to pred, which is going to be, well, name equals. The syntax and the running of these methods is very core data-like. It doesn't compare to anything else. It's not even similar to like getting a file or anything, opening and closing a file. And then with the NS error, create an error object. Automatically we'll do error. We'll have something on error detection, error handling fairly soon here. NS arrays objects here. Execute fetch request for the request. Return an error if not. And then update the status. So if the object count, we don't get any objects back if it's 0, no matches. Else, if there is a match, then matches equals the object at the location that take the object for the address, the phone number, and the status, and update it with the number that we're going to get back with it, but also the name and the address that's going to come back with it. So this one's going to tell us that we have 1 match, 2 matches, or 3 matches, because it's not doing a query. It's doing a different type of request that's going to automatically return the number found in terms of the request. So we're going to pull that out of this array of objects that's going to come back rather than a single object. When you do a query, you get a single result set that comes back out of it. When you do this, it's not doing a query, it's doing a search. So you're going to get an array of objects that are going to be returned from it, so we can print out the number of arrays, number of items in the array that were retrieved. Essentially what we're doing here. Oops, let me cut and paste and put that in the code. And then same as before, actually I'll just move my buttons up so I don't have to worry about it. Copy. And then, let's see. Put this one in the find contact. And then we can add the resign first responders the same as before. Let's see. Missing. Let's make this a little bit bigger. Oops, text. Apparently my paste at this point didn't work. I'm sorry, one more time? Where's the space?
No, matches are found. No matches in the second line of the second line from both.
Yeah, there's like a big old line return in here. You're right, you're right. Matches found. Okay, I still got a problem with this one. It's simply from cutting and pasting, essentially. Matches, what's wrong with the matches? No. No, the bracket sets are good.
At the bottom.
Oh. No. I still got a problem with this line. That's a semicolon. Say that one more time. Ah, thank you. I probably just deleted it on my own. Thank you. So you guys can see more than I can. Alright, now I'm going to cheat sheet the interface so I don't have to put the respond on first. So I'm going to, this is my cheat sheet method here. I'm going to put the save in this corner, the find in this corner. Oh, you know what? Let's just get rid of this guy up here too. I'll put the status up here. Alright, now the keyboard can stay up as long as it wants, I think. It should be alright. Otherwise, you can resign your first responder, do the same thing as we did before. It's the same code. But in the essence of saving time, we'll do it this way. So now I have set to run it. And let's see what happens. So now if I put Bob in here, this is actually a pretty good design. I like this user interface better. Bob's going to have QQQ and 1111. Save him. And we got a message. We got a message because, let's take a look here. Terminate call throwing an exception. Context in the model. Entity. Internal inconsistency exception. Terminating app due to uncaught exception for the NS internal inconsistency. Plus entity for name could not locate an entity named context because context is capitalized in my code and not capitalized in my core data. So I'm going to go back here. And let's just fix it in the core data. I got the error. Oh, this is capitalized. Contacts.
Yeah, it needs to be contacts and C capital.
Oh, it does need to be capitalized. No, I don't think it does. Contact entity name contacts in the model. Can't locate contacts in the model, so I have to put contacts in the model. Correct. So discard changes. Contacts. There we go. Let's try it one more time. I did the capital C, but I made it contact, not contacts. Ooh, now I got a little spiral thing on the bottom here. Yep. SQLite. The model used to open the store is incompatible with the one used to create the store. Interesting. Interesting. I'm going to open the finished product and see if that one runs. Why was calling up an SQLite database was interesting because I'm not using an SQLite database, which might be that there's something funky going on with my emulator. Did it work for you? Okay, good. This one should probably work for me as well. We'll see what happens. I want to say that oh, this is the wrong one. Oh no, this is the original project. So the desired behavior should look like this. Save. And then if I put another Bob in here, save. And then now I find Bob. Find. Oh, one match. Maybe I have a capital Bob and a lowercase Bob. I'm going to add another Bob. Could have been a lowercase and an uppercase Bob. Two matches now. Okay, good. Why my original project wasn't working, I have no idea at this point. Probably because of all of the stuff I was messing around with. Who knows? Again, it is kind of finicky. I probably could have cleared the memory out, probably would have solved it. Why it was complaining about an SQL database? The only problem I can think of is I called the other database contact, but I wasn't calling the database in the project. And I've never even referred to an SQLite database, but I got an error message from an SQLite database. So, long story short, if I were at home, I probably would have just tried to recreate the project, unfortunately, and I probably would have been able to complete it just fine. Or work backwards and start removing parts from the project. All right, last but not least, we have another one. Unless we have questions on core data, the object of the core data was to show you how to use that instead of a database. This one here is really short. Don't worry about it. It's only six pages long. I'm going to skip through the reading. You're going to read it on your own if you're interested. Reading and writing to files. How many people have never done this before in any other platform? Hardly. A lot of people like to read and write into files. This is different than reading and writing to preferences or P lists. which I'll show you in another tutorial. This one is just a raw file. Finding a file, reading to it, deleting it, writing to it. Another way of storing data if you don't want to use a database. Why are you going to do that? Well, sometimes you have a need just to save something. So writing a file, did yours run? Is that what you're saying? What were you saying? Oh.
Writing and reading
Yeah.
data to a flat file, like a
Yeah, it's a flat file. That's what this is referring to. So create a single view application and call it files, or and enter the name of your choice, and use automatic reference counting, and then use to select the storyboard option. So we'll do a storyboard on this one. I probably should, you know, at this point, if I were doing this at home, I would reboot my system. But I'm not going to because I'm recording. Alright, so single view application. Next. And I'm going to call this one files 2. And this time I'm going to name everything correctly so I don't have to remove anything. Use automatic reference counting, use storyboards. This is a single view application. This is not an empty one. Go ahead and click on next, and then go ahead and click on create. And then we have this little files menu that comes up on the side here. And notice we have a storyboard this time. When you click on the storyboard, it looks just like the XIB file that we've been working with so far. And it's just a storyboard. Why? This one probably didn't need to use a storyboard, it just did anyway. Okay, we're going to add a new Coca Touch class to the project that inherits from NSObject. And we're going to call it file operations. So this tutorial is kind of twofold. It shows you how to load a file in another object. We're just going to create an instance of the file operations object and then open and close files and work with it. So we're separating out the logic, taking everything that's associated with the file I/O and putting it into a separate object, a separate class of itself. So add a new class, and we're going to call it file operations. It's going to inherit from NSObject. So that's an easy thing. We know how to do that already. We've been doing it all night. File, new, file. Where did I have clicked? Actually, if I click here, put it here. Let's see, file, new, file. Objective-C class is the one I've got object created here. Now it's going to say NS UI view controller, but we want NSObject. So if I just type in N, I'm going to get the first object that comes up, which is NSObject. And then what am I going to call this? File operations. File operations. So let me get the spelling right. File operations. Okay. Next. Create. File operations. So because it's an NSObject, we're extending from NSObject. So we see NSObject. This is why you're taking Objective-C programming course if you're doing that. This is all Objective-C programming. Well, file I/O is really just basic Objective-C programming. We're just loading it from a UI event. I'm sorry? You have to scroll down to the bottom. Yeah, I mean, okay, very good. Alright, so we're going to open up the file operations.h file and we're going to add some properties. This is not related to the UI, so we don't have to drag and drop or do anything. We're just going to create some old properties. I'm actually just going to cut and paste and stick this here. Oops. Everything in between the file operations and the @end, so @interface @end, same as before. But what we're looking at here is creating some, instead of making these objects inside of the methods, we're going to make it known inside of the class. So, file operations, paste, and wow, I got some line return issues going on here. No, they look pretty good. So I have two method prototypes, one for get document directory, and then one for setting the file name, and one for writing to a single file, and one for reading the file name. So hopefully I have something that looks similar to this. Why n string here is highlighted and n string down here is not highlighted. Beyond me. I have a strange feeling my Xcode is a bit funky right now. Let's see if I save it. Interesting. The highlighting is a bit weird. We'll chalk it up to an error. We'll just chalk it up to an error. we're going to see further on down the road. I'm just kidding. So optimistic at this point. All right, so file.m, where we're going to add the implementations. So we're going to synthesize in this example here, because I don't want to. I like synthesizing, and I don't want to keep using these other names. So what we've done is we've created 2 properties with 1, 2, 3, 4 methods. These are the prototypes. Go through this on a slower pace if you'd like. Change the file to file operations.m. Synthesize the properties, which we've done. So we have file manager, file name, file path, file home. Very similar to the directory. We need to find the location. We need to give a name for the file that we're going to create and use. And then we're going to read right to it. And we're going to set the name of the file to be used. So we're going to set the name of the file to my text file. We don't actually have to put a txt extension on it. This is going to be in our implementation. I'm just going to put it right underneath. So set file name. Set file name. See, it's kind of weird. It's bothering me. Oh, now they're both. No, neither one of them are blue. The color coding is bothering me. Okay, so.
Why couldn't generally in do controller.h, whatever you are writing for all the symbols, they are coming directly into the .m file. Here we need to post it.
Because we're doing it manually. When you drag and drop from the view controller to the .h file and you create the IB actions, you get the methods automatically created for you in the .m file. We didn't drag and drop from an XIB file. Instead, we manually created it. So we have this method set file name. Set file name is over here. This is what I was talking about before. My NS strings aren't blue. But we have set file name right here. So why are my NS strings blue? I don't know. We'll just leave it alone. And then we have set file name here. So the file name is going to be equal to my text file. And then it's going to return the file name. So that's one of our methods. We'll just implement the other methods and we'll see what happens here. So we're going to add the code for the get document directory. So we can just cut and paste and put this in here. Unfortunately, all these methods are done individually. I have to fix the cut and paste stuff. Okay. So the get document directory is going to use the file manager to, oh, that looks good. On here. There we go. Still using the same directory as we used for the contacts database. We're using the documents database. So it's finding the home directory, and the home directory is going to be equal to the NS home directory. So we're going to locate the home directory, which is going to be the string appending path comment for documents. So basically the documents is going to be the sort of similar to my documents, but it's for the user's home directory. So we're going to find the documents directory and we're going to put it in there. Same location as we used before for the context. So first we set the file manager object to the default manager in the file, and this actual example explains to you everything. I'm kind of rushing through right now because I want to get through this tonight. So it sets the value to the user's home directory, which will be the document subdirectory. It's called documents, it's just one directory, appended to the app directory that we'll be using get by the NS home directory method. So create and writing to files. So we're going to writing to the file as easy as the NS file manager. So we need to know the name of the file that we're going to use for the path, and the path that we already used that we're going to use for the get document directory method. So to get the file name, you need to create a method called set file name that returns the file name as the string. So you can use it for the accessor property. So implement the write to file method. So this method doesn't exist either, so I'm just going to cut and paste it and stick it in. So I'm adding another method to perform the operations that I'm interested in doing. And this one is called, here we go, write to string file. So it's going to be a text to write that's going to be the path for a new string that we're going to create. And we're going to throw an NS error. Don't worry about the error checking tonight. I'll go through that in another lecture. File path is going to be equal to the directory document directory. Same thing as we did before in the database example, actually. Set to the file name. Well, the set file name is going to be the file name that we're going to use to retrieve the files and to save the files in this directory. And we're going to use a little boolean to make sure we, we're successful or not. If we aren't successful, we're going to write out to the NS log that we're going to write error writing the file. And then we're going to specify the path name that we're using, and then whatever error message that comes out of the failure. So the method starts with initializing the file path, declares the variables, and then we're going to use a set document, get document directory to get that directory. So, actually, I just went through this stuff. We're going to use a text to write parameter in the write to string file class method. We're going to use. So we're going to do another method that's going to do the opposite of this. So this one was the method to write to string file, which is nothing more than a text file. String text is synonymous. So the other method we're going to implement now is the reading from files. It's going to basically look at the file name that we gave it, get the directory, look at the file name, and read from the file instead of writing to the file. So we're going to implement it from the code here. So I'm going to cut and paste and stick this in here. Believe it or not, we are almost done. Let's see. I'm going to put this on the bottom. I think this is our last method, actually. Then we write some UI controls. And it's going to look at the file the same as before, actually. In fact, if you compare the two methods, they're almost identical except for the reading part of it here. It's going to say if it's unable, instead of writing it, it's going to have a text in file to read from it instead of writing to it. I say go through the code at a slower pace on your own and we'll figure out, we'll see. This is more suited towards the Objective-C students because they're the ones who are going to understand what most of this code is going to do. But essentially we're just initializing new objects when we have a new UI alert view that we're going to use for error checking. The difference is that we're introducing error checking here that we haven't seen yet because we haven't looked at file I/O or anything that would require error checking. And if you haven't noticed in the last couple of examples, we've seen error objects. We create instances of the error objects, and we have the error objects catch the messages that are going to appear when something happens. And in this particular case, we're going to throw up an alert view, which is going to be a little window that's going to say, hey, unable to get the text from the file, and then have a cancel button that says OK on it. And then it's going to essentially return the text file, or the text in the file, as it's running. So the final step is to set up the view controller, make an instance of this in the view controller, because remember, we're still in the implementation of this method here, the file operation. So imagine you've just created this object called file operation. So in the view controller, we'll make an instance of the object, kind of like main, actually. We'll make an instance of the object, run the methods on the objects for each one of the command buttons that we're going to use for the object, which is very similar to writing a traditional style application, actually. It's just controlled by a GUI instead of by the application. We don't have to change the app delegate because we want the app delegate to load the storyboard. We're using the regular old single view application. We just added this file to include the file operations. And I know I ran through the method implementations on the quick side, but we can hopefully take a look at that later on if you have the chance. So the final part here is to create the GUI. So we're going to have 2 labels, a text field, and 2 buttons. So you're going to write something here, you're going to save it, and then you're going to read it. It's going to load it into the label. I could put the labels on the top to save a lot of time with the view controller, with the responding the view. So I'm going to click on the storyboard here, and I'm going to put a text view out here. So I'm going to write something here. I'll even save my prompt too. If you want, you can download the finished product and you'll see it. Then what we're going to do here, put a label. Oops, lots of trash. I'll put a single label here. And I'll make this label here, expand the entire, and then I'll put in here read from file results. Whatever's read from the file is going to go here. Results. And then I'm going to need 2 buttons on here. Should put the buttons on the top, huh? Yeah, move this down a little bit. This is our highly condensed view, so we don't have to put in the resign first responders. And this one here is going to be save, and this one here is going to be read. And it wouldn't be one of my apps if I didn't change the background. So I gotta change the background. Okay, now it's one of my apps. And we'll make it centered. Alright, looks pretty good. Let's see, a little slightly different than the picture here. But save, read, okay. Now we're going to open up the view controller, we're going to wire the components and put in the code for the buttons, and you'll see it's pretty minimal at this point. So we're going to add the following line to the implementation file. We're going to need to make, because we're going to use this, we're going to make an instance of the file, we're going to make an instance of the file operations object, but we're going to use that code, so we're going to have to include the file. So at the top of the .h file, click on the controller, get rid of the side view here. I'm going to add in paste file operations.h. This is in the .h file of the view controller. And next, I'm going to wire the IB outlet connections for the display and the message. So the label is going to be called display. The text field is going to be called message. So display and message. So let's see. This is the display. Display. And this is going to be the message. Okay. And I can synthesize over here. Am I going to need to? Let's see. Yeah, didn't synthesize it. Wire the IB action, or not yet. So wire the IB action for the touchdown event, for the save, and for the read button. So I'm going to call it save and read correspondingly, and I'm going to end up with something like this at the end. I am going to synthesize it. So I'm not going to synthesize it yet. So I'm going to do save and read. I'm just going to wire the touchdown events. Another thing that you may also do is watch this video at a slower speed because everything's being recorded. So if the speed is too fast for you, you can always slow it down and pause it. Which one's this? This is read. I always change the button types. So now I got save and read. I just put lines in between this here. Old habits. So now I'm going to flip over to the viewcontroller.m and synthesize the display and the message. So I get rid of this. Don't like that implementation in there. I mean that interface. Message, display. So now I have them both synthesized over here. Otherwise, I'd have to use the underscore message underscore display. And let's see what else we got here. And now lo and behold, the complicated code. See, now that you have this file operation object, if you create the file operation object, every time you want to create a project that's going to read and write to files, you do the same thing, except you don't have to recreate the file operation object. You drag it in, saved copies of it, you include the header file in the viewcontroller.h, and you run the methods. What are the methods? File operation files, file operation alloc. What does this do? This is, well, from Objective-C, you know, this makes a new instance of the object and allocates and initializes it. And then from files, write to files. What it's going to do, it's going to write to the file the message.txt. And it's going to be a mutable copy, which is just going to be a flag that we're going to put on there that says we can change the contents of the file instead of appending to the file. We can basically change the contents of the file. We can also have it so it appends to the end of the file if we want. We can keep the file and just add to it. There's different choices that we can do. So if you have this, or if your file operation isn't working correctly, you can drag and drop these two sets of files, stick them in any project you want, use them as many times as you want. You don't have to recreate this functionality for you ever again. Of course, you could change the name of the file if you wanted to. Yes?
What is mutable copy?
It's going to change it, make it changeable, so it's not going to append, or it's going to replace. It will replace, when we save it, it's going to take whatever was there and change it with what we have, and it allows you to change it. We can append to the end. If we have options that we didn't use, we can append or we can overwrite. Mutable means it's changeable. It changes versus static, or no, that's not the word for it. Mutable copy, immutable. I don't know what the, yeah, static's a different concept. It means you can change it. It's like mutable arrays. We have mutable arrays actually in Objective-C that we can change the size of the array. They're dynamic instead of being static, which is where I was thinking of static from array context. But mutable arrays are changeable arrays. You can change the size of it at runtime. Here you can change the copy that's being occurred. It's rewritable. How does that make it? Let's see. I'm pasting the code in here, and I'm going to, this one's going to write it, this other one's going to read it. What's it writing? It's taking the message.txt. So whatever's in that message box up here is going to write it, and it's going to write it to the file, and then we're going to have this other one that reads it from the file. When we read it from the file, we're doing the same thing except we're reading file, read from file, take the contents of the file, and store it in the label that we have out there. So I'm going to paste this one in here. There we go. You know what it is the hard return. The hard return made it here. I'm just because of the line, it just word wrapped. So we made two instances, one for the files, one for, we could have called this write file. We didn't have to call it files. Here, read file. It's basically going to run it and make a new instance of the object. Again, we could have taken it out here and made a global object out of it, made the reference, and then kept using the reference over and over again. Same thing I did with the database, which didn't necessarily have to do. So this is kind of the long way of doing it. We could just make the reference and then reuse the reference to that object. But we wouldn't know if we were reading or writing. This is cleaner. There's an automatic open and close for us as well. So let's see if there's anything else in here. This is the first responder stuff. So let's see. I think our app should run at this point. So I'm going to go ahead and run it. Although I have little faith at this point in my Xcode. As most of us get after the first couple bombs out. They just keep coming back. You're like, why do I have so many memory issues? That's when I reboot the computer. Or I take a break and I come back hours later and all of a sudden all the problems are gone. So we'll see what happens here. Reloaded. It's a good sign. I'm going to write something here. Test. I'm going to save it. Oh, and then I'm going to take this out. Oh, read from file results. Well, I don't have to take it out. When I read it, oh, it works actually in test. So I'm going to put here hello world from a file. Save it. Our save button, you know, probably our save button should have cleared it. That would have been an easy one to do. Read it. Hello world from a file. Again. Save. Again. Save. So I didn't bother with the first responder. The rest of it, if you look at the code, actually in the tutorial, will have you wire the the done message to the first responder to make sure that you can resign the first responder, which is the keyboard. Instead, I designed it so the keyboard's on the bottom, which is kind of a shortcut I took at the last minute here. But I could definitely make some modifications to this. But now I know I can read and write to files anytime I want to. Now the poor man's database is to create, to the poor man's view control storyboard, is to create multiple little files, and keep them separately, bring them up and save them. for little pieces of cookie information you want to leave past behind. You could use a database for it if that were the case, or you could use core data for it if that were the case. You have choices. What I didn't show you is loading information from a URL. So the next set of examples will take from out. So this is loading, reading and writing from files inside. I don't have one that shows you how to run, but I might actually think, because I know a couple of people are actually interested in seeing that work over the next break, because next week is President's Day, and we don't have class on next Monday. But I'm toying with the idea of putting together an example, a generic example that reads and writes to a database, a MySQL database that's on an internet server. You know, I'm going to torture myself with that example. We'll see if it works. No promises, but I'm going to work on it in my week off, maybe. The other thing, I have a tutorial coming up that will download an image from a URL, download a text file from a URL, and then upload an image or upload a text file to a URL location. This is performing something very similar to an FTP operation, a GET, wget if you're a Unix person. It's very similar in concept. It's not doing anything that you can't, but it's exchanging information from the app to the world and then back and forth, which comes in handy as well in terms of data exchange. So anyway, you can take a look at this at a much slower pace and read through the comments at a much slower pace and probably understand more about what the code is doing. In the essence of trying to get you out before 9, I decided to shortcut it a little bit. Any questions on reading files using databases or core data? We have actually accomplished everything we needed to accomplish for this evening. I will definitely, as soon as I stop this video, kind of come around. If any of you do have any questions or anything, I can try and figure out if I can solve your problems. But at this point, my suggestions are to start over. So, anyway, on that note, I'm going to end this video. So.